Example 2, graph the function y equals 2x minus 3 over x minus 1, identify any asymptotes and intercepts. So we are going to convert this to y equals a over x minus h plus k form, but I just want to talk about asymptotes first this time. If I was just asked the asymptotes, I don't need to do that to convert the form. I can tell that the non-permissible value would be x cannot equal 1. So I know I have a vertical asymptote at x equals 1. I then compare the degrees. Degree in the numerator is the same as the degree in the denominator, so it's the leading coefficient, so 2 over 1. So the horizontal asymptote is y equals 2. Now let's find our a value. So when we go to graph these, we know, and then we'll confirm our x and y intercepts as well. So I'm going to do synthetic division. Bring down that 2, multiply, add. So we get 2 minus 1 over x minus 1. So my equation looks like this, negative 1 over x minus 1 plus 2. So the a value is still 1, so there is no stretch, but there is a reflection. So it was definitely great that I could do that, as I wouldn't have noticed that in the original equation. It's right 1, which still supports x equals 1. It's up 2, which still supports y equals 2. So it also helps confirm. So I usually look at both methods there. Right 1. We're going to do like so. Okay. Now I'm going to, remember we're used to drawing them in these two quadrants, but now I'm just going to use pencil. It's a little easier to get these points when they're smaller. Now it's in these quadrants here and here. Okay. Now 1 just means that I'm going over 1, up 1, which basically puts you in the same spot. Turns out that must be the y-intercept, and I have 1 here. Now, remember with those graphs with the 1, we knew they were also at the 1/2 away from the asymptote, so I know that as well, which confirms my x-intercept, though I'm going to find that algebraically to make sure, but I know those are at 1/2, so I like to plot them too. Okay, so now let's just make sure our intercepts are right. So y-intercept, let's confirm that. Y-intercept, you're going to put in x equals 0, and you'll notice it's really the constant terms divided by the constant term, so you get 3. So we're right there. And then my x-intercept, we're going to let x equals 0, or sorry, y equals 0. And when we do that, 0 times x minus 1 is 0, 2x minus 3 divided over 1. So what happens every time when you're finding these x-intercepts is the 0 cancels out that denominator, and you're really just finding the 0 of the numerator. So we get 3 equals 2x. So x is equal to 1.5. And if you look, that's exactly, I said that was halfway, so it's at, the intercept was at x equals 1.5. So these intercepts were part of what's said to be stated as well as those asymptotes. So you've got a couple strategies. If you were ever stuck, you could also, once you have like intercepts in here and asymptotes, you know, test some key points. But the idea is that you want to convert it to this form so that you clearly plot those vertical stretches in there as well, and you can see the transformations that result.